hello and welcome to the first of today's debates from SMTConnect. Yesterday we held a very successful conference for the eSmart Factory Conference at the Sheraton Carlton Hotel here in Nuremberg. And I'm delighted to be joined by three of the speakers from the event yesterday. We have Kristen Vogelsang from Keysight.
Hello.
Hello, nice to see you. Then we have Eyal Weiss from Cyborg. Nice to see you, Eyal.
Nice to meet you.
And of course, Michael Ford from Aegis Corporation.
Nice to see you.
Nice to see you again. Okay, so it was a really interesting day. As you said earlier, just before we started, Michael, there's a lot of synergy between the presentations and the technologies that we discussed. But the first of the debates, or the first presentation actually, was the keynote, which came from Stefan Kronert, discussing the merging of SMT and back-end assembly and where the synergies were in that. What did you think about that?
It's reflecting a trend in the industry which has been going on, but I liked the way he drew attention to it and explained it, because there are a lot of opportunities that are going to come now for other parties within the industry to take advantage of the situation, to create the synergies between the kind of manufacturing they're doing, either in the semiconductor or on the assembly, but putting them together. But it's like two tectonic plates meeting each other, and there are going to be a whole ridge of earthquakes in between. And that can be a good thing because it gives people the incentive to improve things, to decide how to do things the right way. So he went into explaining why it was happening and the graphics that he was using to illustrate it. I'd not seen those before. And so even though I kind of knew what was going on, he made it very, very clear and easy to understand. The next question is, how is that going to affect business opportunity in Europe?
Yes.
And so I think he set the scene for people to start thinking about that in a very good way.
Yeah, no, I mean, it's true. And I do know of a few companies that are SMT companies that are starting to put clean rooms into their factory spaces and things like that to handle back-end packaging devices, you know, especially in mission-critical stuff like military and that type of thing. Kristen, what were your takeaways from the test perspective yesterday? Did you learn anything, or was there anything really interesting?
Well, there were a lot of things that were really interesting, of course. One of my major takeaways is that it's no longer part of hardware and testing stuff, that we go more and more digital. And it's not only displaying test measurements on a monitor, but it goes far beyond. It goes to understand what we are testing, improving the tests. And the next step is to enrich the jobs of the people by using those measurements, by using digital abilities, and change the jobs in the way people love to work. So this was one of my takeaways, and I think we've seen it in several different discussions how digitalization is coming into testing, and well, it's no way out.
Yeah, I mean, honestly, there's been quite a few companies have introduced modernization or digitization and automation. I haven't heard of anybody laying people off because of it. You know, they've redeployed them into other jobs that are more interesting, but I haven't heard of anybody really laying people off because of that kind of thing.
I'm kind of expecting the opposite, because people, their perception of manufacturing is you've got a machine, you have to do a deep dive in understanding exactly how it works. There's lots of dirty bits to look at, oily, greasy bits and alignments, and that's just my impression. It may not be the truth, but you know, that is people's impression. But now, for example, the kind of presentation you made showing how the data is collected and how it's used, this brings a whole new set of skills, so that you're no longer dependent on the guys or people who are doing the very deep dive and understanding the technology, but actually you're introducing something that's a lot more exciting. Being able to understand how things interact with each other, how can I influence things, how can I create things in a way that they would never have had the opportunity to do before.
Right. Okay.
I think you're right. People seeing the involvement of AI and what it brings to you, letting you see all the analytics tool and the BI tool. So every operator on the line can see the big picture.
Yes.
which is much more empowering than just doing the technical job that they're doing so far. So I agree. Taking this step upward will, I think, empower the people to do more. Even people who are technical in nature will feel they see the bigger picture and be able to control it more.
Yes, there was a lot of talk around AI yesterday, and some of it was quite interesting. You started off yesterday with the example with Chat GPT, which, of course, as we all know, first of all, you have to know what you're talking about to use it. But secondly, it's not always accurate. It'll bring in information for sure. It'll present it nicely, but it also brings in a couple of inaccuracies, which is a little bit concerning.
Yeah, I kind of equated it to what we see being amplified in the media, where if you have a source of information which is not quite correct, then that's going to be taken by an application like ChatGPT. It doesn't have a moral compass. It doesn't know what's actually right or wrong. Its skill is being able to represent that in a kind of generated form that makes it look really exciting. It's very much what people would want, but the content, okay, it's a little bit dubious. But what happens is that becomes an amplifier of things that aren't quite true, of people's opinions, which are valid, but they are people's opinions and not facts.
Right.
Now, if you were to transpose that into the manufacturing area, and you're starting to apply the same logic to data which is not contextualized. So the data may be true, there may be gaps, but what does it actually relate to? What does it mean? It may come up with an incorrect conclusion. Now, that's not going to result in a Terminator movie destroying the factory, but what it might do is to make decisions that confuse people and maybe are not the most optimum ones.
Well, you could end up making batches of bad boards, and having recalls or something like that.
You really could, yeah.
I think basically people are now more exposed to AI through ChatGPT, which is specializing mostly on text or NLP. But for every, technology that we address within the production line, within the SMT, and also within the packaging that we talked about in the first talk, people are trying to see how they can use this technology to do better. So most of the machines trying to control the process, the measurements, the operations of the line, the optimization, bringing the data back to the people. Every aspect is addressing. And I think the winner is going to be, the winning is going to be the right fit that will really utilize the power of this big data, because basically NLP and AI are all based on the new capability of machine learning and big data. And everybody is trying to find the right fit, and there will be winners, and there will be the fits, and there will be the ones that are not exactly there.
There were many presentations yesterday that were quite exceptional. You two are here, so I'm going to pick up on yours as examples, because, for example, being able to identify a material before it has the opportunity to cause a serious quality issue, that could not be done by an army of people. However, one person armed with the right information makes a huge difference. In the in-circuit test, there are so many things going on in parallel. How do you focus the resource to improve the reliability of how fixtures are working or how probes are working as they naturally go through their life cycle? An army of people couldn't look at that fixture or the pin set and really be able to understand where's the best use of my actions. Whereas you show that it's very, very simple, seeing the result of the AI to focus my attention and get the maximum result. So these are real-world, practical, benefit-driven improvements for manufacturing. That's what we should be focusing on, not how do we define an AI.
Right.
And so we had a lot of fun talking about AIs, but we also saw the more serious picture of how these benefits are made for actual manufacturing today.
Go ahead.
Okay. Chris?
Well, we had exactly that in mind. We had a I personally have experience of a product I was working on, lifetime project that almost failed because of components. So I saw a need to be able to check components before they're used, so to avoid what I experienced firsthand. So this is my fit that I found because of big data and AI now allow it. Until just a few years ago, it was an impossible task. When we were addressing people saying, hey, you can now inspect every individual component using AI and make sure it's not counterfeit and not defective and so on, people will tell us that we're crazy because it's just not possible. But the AI and the big data now allows us to do that. So you can find defects that were never available to you to be detected before. So we took it to this place. And on the other side, the industry is using it for other things. Like, for example, what you were presenting in the talk, which was also a very practical way to use this big data and AI methods.
Yeah, thank you. And I think if we look at the time, it's been different. If we look 10 years ago, it was a matter of if we are using digital transformation, are we going to transform? What's the cost of transforming? And I think yesterday it was pretty interesting to see nearly everybody covered also the part of sustainability. So it's no longer we pay for being digitalized, but we get something back because we improve quality, so we have less scrap, we have less things to throw away. And one summarized it a bit sarcastically. It said, we are in Europe, we have to talk about sustainability, but I think it's no longer just a European topic, and we'll go there, and digitalization will definitely help us, especially improving quality and things like that. So it was great.
Right. So one question I've got is that how much of the control stays at the local level with the test equipment, and how much of it goes up into the MES? Because there was a comment made, I think it was way back at Apex, it wasn't yesterday, about the desire by a certain MES company, I won't mention names, to eliminate test. So I'm thinking, why, so they're obviously wanting to take control of that data. They still want to have the eyes and ears of the inspection equipment on the line, but they want to take control of the data, was my interpretation of it.
I think that's crazy because you have machines that have a specific purpose in mind to do, and there is a level at which decisions are continuously being made to optimize that machine operation, to take care of abnormalities or anything that may show up because of materials or something like that. You then have another layer, maybe machines talking to each other. It's a different kind of data that they're sharing, a different kind of function that they're doing, but that's absolutely valid, these closed loop solutions that we saw examples of yesterday. But then you go up to the factory level, and yes, there is an element of control, again, that comes on this different level that ensures that products are treated in the right way. But that's working in real time. So you've got limited computing power actually on the shop floor. And so you send the data up to AI, for example, your AI, where you are then making the further analysis. When something then goes wrong or is detected as an anomaly, you need then to make sure that appropriate action is taken. And so that is fed back down to the factory level where we can start to quarantine machines or materials or processes. So in reality, you have these different layers and they all work within themselves, but they all contribute to each other.
I see.
That's the better way of thinking about it. Yep. And in terms of test and inspection, if there wasn't test and inspection data, you wouldn't have Industry 4. Because all the other machines tell you is what they did, and all they do is what you told them to do. Yeah. So therefore, what's the point? It's just a confirmation.
I think reading between the lines, I think essentially what they were really meaning to say but didn't say was they want to get rid of all the defects. In other words, there shouldn't be defects because we should be able to predict them. And that's it.
If you're talking about defects, absolutely with you, because I think you showed that when you are analyzing the data, you're not looking for the analysis of defect conditions, you're looking for analysis of all conditions. And it's the runtime data that's more important. But that can be done at the machine level. That can be done within your software level. It can could be done at MES level, but you're getting into an area which is a little bit outside of MES, to be fair.
Exactly.
An AI linked together with the machine process that knows the machine process is the most efficient way of doing it.
Yeah.
So yeah, I agree with that concept of the elimination of defects, which quality people will love but not believe, but actually you could conceivably get there. But we need to be, very careful to make sure we understand the role of each layer.
Actually, Michael, you were talking about this in your talk about having the context. AI works very well if it understands the context of what is seeing. If you give him something out of context, you will get garbage.
Yes.
Now, if you're, or let's say on a micro space, looking at something very individual, your context is very limited to what you're seeing. But if you're getting a larger and larger view, getting context from different machines in the line, different aspects of the design, and how they affect everything, your context may be much more tuned, and the quality of your predictions makes sense.
Yeah.
So getting, well, like you said, higher and higher, by making the machines talk in the same language and by sharing information between systems, a machine, for example, can forward information to the next machine. Let's say if the SMT, if we detected an issue with a component from the SMT machine, we can forward this information to the AUI machine and tell them, hey, there's a suspicious here, take a second look at it in a different way, because there's something to be gained by information that we got from the machine in the upstream. So getting the context and get it to work in the right way may be the key to utilizing AI in an effective way in the SMT world.
Yeah, absolutely. So yesterday we had a whole range of different presentations, and there was one in particular that we all saw that was like taking a look over the hedge, if you like, into another world. That was the world of medical devices, and we had a presentation by Dr. Despina Musho from the University of Bath on the challenges of combining electronics with microfluidics for measuring different diseases and systems, and that was fascinating. I mean, who wants to talk about that first?
When I saw that presentation, it brings home, first of, as you said, it's the combination of two areas of expertise, which you rarely get these days in academia. So she's quite unique, but her approach was to really understand why, let's say COVID tests, just as an example, why does it take so long? Why does it take half a day? And the frustration and cost and all the rest that goes with it. And she said it doesn't need to be like that. She knew that the surface area, I mean, you asked a question in the meeting, what about the size? How does that affect the speed and the movement of all of the, she knows the detail, look it up, but the movement of all the different chemicals and the combinations, and it just brings a result in 2 or 3 minutes. And so that for me is just like, why didn't we do that before? But the combination of having that within a circuit board, a little thing that you effectively just lick and get a result, it's amazing. Absolutely. And so for me, it really opened my eyes to an application within electronics, which is not necessarily for electronics' sake. It's for our health and safety's sake, doing all kinds of things from cancer detection to all the other ranges of diseases. Yeah. That just blew me away. Yeah. Because,
I think one of the interesting things was, of course, that she's working in a medical environment, but she's come from a microelectronics background. And so she approaches it with that mindset to try and solve the problem.
She really did a good trick here, because what we're saying, basically what she said, answering my question there, was the smaller you get, the more effective you can be. Now, she understood that going much smaller to microelectronics is going to be very difficult, because you need much more expensive processes and very long cycle times to develop. And she found a way in between using PCB technology, SMT technology, which is a step in between. So it's very effective in the maturization of her technology, of this technology, of the lab on chip technology, to not do it lab on chip, do it the lab on board. So it's a very effective way to bring results very quickly to the industry and test concepts and values without paying the very expensive price of going to microelectronics.
Right. No, I agree. You any thoughts on that particular presentation?
Yeah, what I liked, of course, was the idea of bringing electronics in a part that we haven't seen before. The sad thing about it is that it always comes up to the price. So why are we not using it? We are not using it because it's quite inexpensive, more or less. But she was able to see the next step. So she was taking it to do cancer measurements. And in cancer measurements, there is a lot of money left, even more than in COVID research. And she's taking it to all the places where human beings can't exist, into the plane, to test water quality, which could be a great improvement for third world countries. So I think it's brilliant to see, and very good idea to invite her to see what she is doing, just to open our horizon. Yeah.
Actually, that's the point I was trying to remember. The cost. Because you mentioned the difference in levels of cost between medical and electronics. So if we had one of these little PCB things that can detect cancer, diabetes, and all the rest of it, for $1,
Right.
that's not bad for a circuit board. But you compare that to the cost that we pay for COVID test kits. Now, okay, that's the creation cost, so obviously people are going to, do their business thing on it. But it really hits a need in the market for mass testing. So we could imagine a world where everybody has these things to hand, rather than being, you feel unwell, you go through a long, convoluted process of trying to see a doctor and all the rest of it. The revolution is that you could do it yourself. Now, obviously, doctors hate people self-diagnosing, but this is an actual device which is, you're going to use it and it's going to show a result, which you just send over the internet to the doctor. That short circuits a huge amount of waste in the medical system. So apart from the technology, we're changing the way the health service works and making it so much more efficient.
Absolutely.
And I think this also showed how good decentralization could work in future, and how those miniaturization combined with electronic PCBs and whatever can lead us to more kind of self-fulfillment, or being more self-responsible, not only for working, but also for health, for testing. So I think this is brilliant to see,
Yeah, absolutely. So anyway, wonderful conference yesterday. Thank you all for your contributions to it, of course. We will be broadcasting it again in US time, actually, for some of our US viewers that weren't able to join us yesterday. That'll be coming up in the next few weeks. But for the meantime, I want to thank our panel today, Kristen Vogelsang from Keysight, Eyal Weiss from Cyborg, and of course, Michael Ford from Aegis. So thank you all for joining us, and thank you for watching.